in lesson 19 today, we're using our piecewise functions to solve problems. So it's not just a matter of graphing them or taking the graph to make the equation, it's actually using them to solve a problem. So our first one, the function f of x is shown graph below. Which of the following is the value of f of 2? So you can see how it was named f of x. Now you're finding f of 2. That means find where x is 2. So we go to our graph, x is 2 right here. We follow it till it meets the graph. And then follow it over to the y-axis. What's the value? And our value is -1. Moving to our next one. For the piecewise function defined, f of x equals 3x plus 1 for x less than 3, and 1/2 x plus 7 for x greater than or equal to 3. Determine the value of f of 6. Alright, so we are testing an x value of 6. We then come to our intervals. Which one do we fall into? Is 6 less than 3, or is 6 greater than or equal to 3? And we know it's greater than or equal to 3, so because it falls in this interval, it means I have to use this equation. And I substitute the 6 into the equation. Half of 6 is 3, plus 7 makes 10. Alright, so given another function, I need to figure out what is the value of f of -1. So again, I'm using -1. I have to decide which interval that falls into. -1 is less than 2, so I use my first one. 3 times -1 is a -3. So it's -2. Alright. The equation to determine the weekly earnings of an employee at the hamburger shack is given by w of x, where x is the number of hours worked. So we have our function, w of x equals, it's 10x for values of x between 0 and 40, 15 times the quantity x minus 40, plus 400 for values x greater than 40. So for part A, we want to determine the difference in salary in dollars for an employee who works 52 hours versus one who works 38. So we want the difference in their salaries. Difference is subtraction. I have to figure out what their salaries are first, though. So 52. Which interval is it falling into? 52 is greater than 40, so I have to use my second equation. Replace x with 52. And solve it. Only 38 hours. So again, which interval does it fall into? 38 is between 0 and 40, so I'd use the first one. This person gets $380. Now it tells me I need to find the difference in their salaries. Part B. Determine the number of hours an employee must work in order to earn $445 and explain how you arrived at your answer. Alright, so I know my equations are determined by their number of hours. We're being asked to determine a number of hours. The difference is in my intervals at the 40-hour mark. Okay. So if we think about that, at 40 hours, that is our first equation. That person at exactly 40 hours earns $400. Well, in my example, this 445 is is greater than that 400, and that's the most you can earn from the first equation, so we want equation 2. So now it's a matter of like old-fashioned solving for x. I'm going to take the 15 times x minus 40 plus 400, that equation 2. Okay, just took equation 2. We seem to be back to this fun stuff, so bear with me. Set that equal to 445. So you can see that it says to explain how you arrived at your answer. This explanation over here of how I chose which one pretty much does my explanation. So it's your choice how you choose to do it. Remember our list of steps we've been practicing. Use the distributive property to get rid of the parentheses. So we distribute the 15. Step 2 says to combine like terms. Step 3 says to move all our x terms to the left side. We don't have any x terms on the right side, so that part doesn't matter. Step 4 is to undo the addition and subtraction. So I'll add the 200. When this comes up on the regents, if you work nicely like I have been, you can just do that too and show people where you have to go. And then last is undo the multiplication and division. So 645 divided by 15. This person worked 43 hours. Okay, number 5. When a diabetic takes long-acting insulin, the insulin reaches its peak effect on the blood sugar level in about 3 hours. This effect remains fairly constant for 5 hours, then declines and is very low until the next injection. In a typical patient, the level of insulin might be modeled by the following function. Okay, so they've modeled what they just described in words in this function right here. So 6 a.m. to 7 a.m. That's 1 hour. So that means t is equal to 1 here. So I go back, which of my equations is the one in? One's up here in the first one. So in place of t in the first equation, I put my 1, and I find it's at the blood sugar levels at 140 at that time. Moving to 11 a.m. The patient took the insulin again at 6 a.m. So 6 to 11 a.m. Right, so that means it is 5 hours. T equals 5. So again, looking at my intervals, 5 falls between there, and it's just a constant steady. At that point, it said it kind of leveled off and stayed. Okay, so 3 p.m. 6 a.m. to 3 p.m. How many hours is that? Okay, 6 to 12 is 6 hours, plus another 3 more. I'm going to do t equals 9. Checking your intervals, which equation? 9 falls into the third interval, so it's the third equation. And this is where they said it started to drop again. Plug it in. Get 140. 6 a.m. to 5 p.m. It's just shy of 12 hours. T equals 11. See, that falls into this spot, and it tells me it stayed steady again. It's just at 60. Next page. Give an example of speed versus time. The graph below shows how the speed of a bus changes during part of its journey. The equation, hold on. Alright, so some things change a little bit. That example was different than what you have in your notes. We're going to just skip the last example in your notes. Taking a look at the homework. Sorry about the bell. For the homework, you're practicing putting it all together. And we're going to have you do all of it, numbers 1 through 5. Good luck, see if you have questions.